Hi, let's try this question. This question is taken from SPM 2022 Paper 2 Section B and it is from your Form 4 at Math Chapter 6 Linear Law. Now let's look at these questions. Table 1 show the values of two variables x and y obtained from an experiment. The variable x and y are related by this equation such that a and b are constant. Now we are given a bunch of value of x and the value of y. So for the first part, we want to plot y times square root x against x. This means that the vertical axis is y times square root x and the horizontal axis is x. We want to plot this graph using a scale of 2 cm to 1 unit. So 2 cm means that a big square grid. So now if you have a graph like this will be 2 cm. Okay. So 2 cm to 1 unit, it means that 1, 2, 3, 4, and so on. For on the x-axis, horizontal axis, and 2 cm 2 unit on the vertical axis. 2 cm to 2 unit, it means 2, 4, 6, 8, and so on. Okay, after plotting the graph, we need to draw the line of best fit. Okay, so first we need to calculate the value for this one. This one we don't have to calculate. We already have all the value here. So I already calculated the value just now. Now, how do I get all this value? It's actually very simple. You just need to take out your calculator. We want y times square root of x, right? So you just press this one times square root of this. This times square root of this. Let me show you a few. So negative 0.79, for example, this one, times square root of 2 times square root of 2. Now you got the answer, negative 1.12. How about this one? 1.29 y, right? Times square root of 3.5, square root of 3.5. Okay, 2.41. Okay, just do the same thing for the rest of the value of x and y. After you got all this value, then you can start to draw the graph. So as the question requested, 2 centimeters to 1 unit for the horizontal axis, 1, 2, 3, 4, 5, and so on, and 2 cm for 2 unit for the vertical axis, 2, 4, 6, 8, and so on. Okay, my graph may be not that accurate, but I will use this graph to explain to you. So you can try to draw on a piece of graph paper and draw nicely. You should be able to get a really accurate graph. Okay, now. So let me show you how to plot this graph. I think majority of the students should be no problem to plot this graph, right? You learned before. Okay, let's say now look at for this horizontal axis, we know you can write this one, write down this one so that easier for you to plot the graph. It's up to you, this one, what I'm writing here, no mark will be given, this one, just for your own reference. So a small grid, so 10 small grid is equal to 1, a small grid will be equal to 0.1, okay? So this, for y-axis, but this is actually not y, this is vertical axis. But this is only for our own reference. If you want to write y, it's okay because no mark will be given to you for this one. So let's say you want to write this one, it's okay, up to you. Okay, now a big grid is 2, right? 2. So I'm going to divide it to 10 because a big square grid, we have this, here we have 10, right? 10 small grid. So I'm going to divide it by 10, I will get 0.2. So for example, I'm going to show you how do I plot this point. So I'm going to take out my calculator. For the x1, no problem, 1, right? So how do I get this one? You can calculate one by one, but I think it's take time. So another easier way is just forget about the negative. You just think about 4.7, right? Okay, key in your calculator 4.7 and divide it divided by 0.2 because we know that a small grid is 0.2, right? So divided by 0.2. So from here, I know that I need 23.5 small grid. So this is 10, 20, and 23. 1, 2, 3, 0.5. okay, between 24, 24, 23rd and 24th. Okay, now let me show you another one. How about this? How about this one and this one? Same thing, 2 should be no problem. And then you just key in your calculator 1.12 divided by 0.2. This one, press equal 5.6. Okay, it's 5.6 is very hard for us to get the very accurate. So we just plot around 5.5 means that before the between the 5th and the 6th small grid. So let me enlarge it to show you better, let you see it better. Now, can you see it? Okay, let me make it better, larger. Now this one, 1, 2, 3, 4, 5. So 5.6, right? So I just roughly plot between the 5th and the 6th small grid. So around 5.6, around 5.5. It's okay. It's very hard for us to get 5.6 just by our naked eye. Okay, so this is the idea. How do we plot this graph? You can use your own method as long as you are familiar with that method and you know how to plot all the points correctly. Okay, after plotting this graph, use a long ruler to try to adjust your ruler so that you will be able to get the line of best fit. So sometimes, a lot of time, many times, we are not able to get to connect all the points together. So it's okay, but try to distribute the point that you cannot connect them above and below. You see, this above, this below, this above. Try our best to get the line of best fit. So I think my graph not that accurate, but you can try to draw it on your own on a piece of graph paper. If you draw it nicely, I think you should be able to get a quite accurate graph. But your answer may be slightly different from the given answer. But don't worry, for this sort of question, right, there will be a range for the answer. As long as your answer is within that range, then your answer will be accepted. Okay, now, so next thing, after you draw this graph, right, you can use your calculator to check your answer. So how to check? Press menu and then go for statistic number 6, statistic. Okay, choose the second one, y equal to a plus bx. This is our gradient, and this is a y-intercept. What you need to do, just key in this value and this value. Okay, be careful. You need to key in this one, and this one, not this one. Okay. Now, 1, 2, 3.5. Be careful. 3.5, not 3. Then 4.5. Okay, then 6. And 7. Now let's go to the vertical axis. This is negative 4.7, negative 4.7, and then negative 1.12 and 2.41. Okay, then 5.6, 8.6, and last one 12.2. Okay, then press option. Then choose number 4. Okay, can you see it? This one. Now, the answer given by the calculator is the y-intercept should be 6.996. So very near. Sorry, not 6, negative 6.996. So very near to negative 7. But what I got here is negative 7.3, and the gradient is 2.707. Okay, so I try to draw it using this GeoGebra. So this is a line of best fit. But when you draw on a piece of paper, right, because we draw it, plot all the point by naked eye, maybe the line that we get will not exactly the same as this one, but should be very close. Okay, so your graph should look something like this, but maybe slightly different is okay, as long as your answer that you are going to calculate later within the given range, then your answer will be accepted. Okay. Okay, now let's go back to this one. So for part B, we have done the part A, draw a graph and draw the line of best fit. Okay, now let's go to part B. What do we need to do here? Find the value of y when x is equal to 5.7. X is equal to 5.7. Okay, I think here. So look for 5.7. 5.7. Draw a dotted line, go up, touching the graph, and then go horizontally until the vertical axis here, and read the value. So what I got here is 8.5. If I use this graph generated by the software, I will get 8.43. Very close, very close. I think it should be okay. Now, but you have to be more careful. The answer is not 8.5 when x is equal to 5.7, which is here, 5.7. Y is not equal to 8.5. The 8.5 here is y times square root of x. So y times square root of x is equal to 8.5. But the question is asking y. So what do you need to do? You need to do some calculation. So x is equal to 5.7, right? So I'm going to substitute the value of x inside here, and then do some calculation. Just press your calculator. 8.5 divided by 5.7. Okay, I just round off my answer to 4 significant figures. 3.560. Okay, this is the answer for this part. As I told just now, your answer might be slightly different from me. It's okay, as long as our answer is within the given range, then will be accepted. Okay, now let's proceed to the last part. Write AY, write this one. Okay, let me cut this one. We want to write this in the linear form, and then we want to find the value of A and B. Okay. So we want to write in linear form. It means y equal to mx plus c. So what I'm going to do, I'm going to make the big Y become this, and then the big X is X. Okay. So now I want to get rid of the A here, right? So because I know that the Y must be equal to y times square root of x, and the big X is still the same, x. So this is what I'm going to do. So first, I'm going to divide the whole equation by a. Divide the whole equation by a. So here I will get y. This will be b over a times square root of x, and here will be 1 over a times square root of x. Okay. And next thing, I want square root of x beside the y, right? So I'm going to multiply the whole equation by square root of x. So here I will get y times square root of x. Here, square root of x times square root of x, you will get x. So here will be b over a times x. And here you will get 1 over a. So we have written it in the linear form. So now this is big Y and this is big X. So we can start to find the answer for A and B, the value of A and B, using our graph. Okay, so to get the gradient, let me calculate the value of A first. So this one, Y equal to mx plus c. From here I know that 1 over A is actually the y-intercept. It's a big y-intercept. Right, so I'm going to use the value here. So if you use you can use your own value. Maybe you will get -7, right? If we calculate using our calculator, you should be able to get -7. Here also -7, but this already round off it. If you let me make it to 4 decimal places. Really close to negative. It's impossible for us to get this one. So if your graph is really close to the answer given, it should be -7. Anyway, I will use the answer that I got here to explain to you. So -7.3. 1 over A, 1 over A is equal to negative 7.3, right? So A is equal to 1 over negative 7.3. Just press your calculator, 1 over negative 7.3. Okay, negative 0.1370. Okay, this is the value of A. Now, we want to find the value of B. You know, this is a gradient, right? This is a gradient. So you need to get the gradient, calculate the gradient of the graph here. So some students like to, you can choose any 2 points that you think is easier for you to calculate the gradient. So you can draw a right angle triangle here and then calculate the vertical distance and the horizontal distance and find the gradient. But if you are using this method, you have to be more careful. For example, sometimes you will have a graph like this, for example, going this way, and then you draw a right angle triangle. For example, I just simply give a value. Let's say this is 2, this is 1, and you say that the gradient is 2 over 1 is equal to 2. This is not correct. Why? Because it's going downward like this. This gradient is negative. You have to add negative yourself. Okay, you need to be more careful if you are using this method. If the graph is going downward like this, remember to add a negative for it. So if you don't want to do it this way, you can choose any 2 points which lies on the straight line and use their coordinate to calculate the gradient. So here, I think I use this one and this one. Okay, so this one is 7, comma, I just write 7. You want to write 7.0, it's okay. Same thing. Okay. So this one, 1, and negative 4.7. Okay, I'm going to use these 2 points to help me to calculate the gradient. So the gradient here is equal to B over A, right? So 12.2 minus negative 4.7 over 7 minus 1 is equal to B over A. We got the A just now, negative 0.1370. Negative 0.1370. Okay, now let me calculate this one first. 12.2 negative will become positive, plus 4.7 and then divided by 6. Okay, the answer I got here is 2.817. Okay, very close to the answer here. So I will use this one, 2.817. Negative 0.1370. Okay, so B is equal to this one times this, 2.817 times negative 0.1370. Okay, it's equal to negative 0.3859. Okay, this is the answer for this question. That's all for this video. See you in the next video. Bye bye.